Good afternoon, everybody. Thank you for coming. Coming to my talk on augmented development with the subtitle Successes, Surprises and Pitfalls. My name is Andy Bailey. I work for a company called Veda GmbH, or GmbH as we like to say in Germany, of course. I am team lead for a project which is just started, hopefully coming full stream at the beginning of the year, which is beginning of next year, which is to take 5.5 million lines of RPG code and use AI tools to migrate it to Java. I have been involved with Java from the very beginning, October 1995. I discovered the SDK on Sun, and since then I've been playing around with it and been a professional back-end developer for over 25 years. So enough about me. What is augmented development? It is the use of AI tools to aid in software development, of course. But unlike vibe coding, frequent inspection of the generated code is required to ensure quality, coverage in tests, and quite often performance. But for this, I decided that I'm going to do it deliberately wrong. I'm not using guidelines or extra guardrails. I deliberately delay code inspection until after JUnit test generation. I just use prompts. So this is pretty much how an experienced dev might approach this. Or an inexperienced, sorry. The subject of my talk is a GitHub repository project called Fast Decimal, where I want to create a replacement for big decimal with the following constraints. The scale value contained in a long, fixed scale of 4, and only use rounding mode half up for divide. This must provide acceptable accuracy to 4 decimal places, and be able to scale computations using SIMD, with using the vector API, and even GPUs. I chose this for an attempt at augmented development because it is limited in scope. It is literally just 2 classes with the vector API involved. The tests should be easily generated. There are possible real-world applications because big decimal is a performance murderer. And it's easy to measure performance against big decimal using JMH. So the AI agents I chose for this, using IntelliJ IDEA, were the AI chatbots ChatGPT-4, Claude Sonnet 3.5, and Gemini. I can't remember the version, and it's not really that important because it was a bit of a disaster. And then later on, Junie, for reasons which will become obvious very soon. I provided some basics in the fast decimal class. As you can see, scale factor, scale digits, also the maximum representable value and its minimum representable value, which is important because if I can't use expand in this, so I can't expand the data type. So, how do the agents measure up? My first prompt: create a factory method that accepts a string representation of a decimal value, converts that value to a scaled value for fast decimal using the scale constant. What happened? Well, first thing I learned is you don't always get what you ask for, you often get way more. Without exception, the first 3 agents provided code that simply delegated everything to big decimal for construction to the add, divide, multiply, and subtract operations and more. All the public methods in big decimal API were implemented and delegated everything to a big decimal instance. So what it does is it actually took the fast decimal value, the internal value, the scaled value, and converted that to a big decimal, did the operation, and then converted it back to a fast decimal, new fast decimal value. So it's no, sorry, that's not what I wanted. Here's a snippet of code. As you can see, the of method returns a new fast decimal out of a big decimal with setting the scale to what I wanted, but not quite what I wanted. And then at the end of the day, shift the long value back into fast decimal. So much for replacing fast decimal. This pattern was repeated for everything. It didn't even use the scale value constant I kindly provided, which is kind of annoying. And this is all 3 of them that did this, just for the of method. So why did this go so wrong? Well, at the very least, these were missing. My prompt did not tell the AI to use scale values, the scale value constant, and the other constants as well. And it should have told the AI to use the big decimal API as a baseline for methods of the fast decimal class, not just simply to delegate everything. So from there, I went to the tests. So given that everything was delegated to big decimal, having the agents provide unit tests would be easy. And in the meantime, I'd also asked the 3 different AI chatbots to generate the 4 important methods for add, multiply, subtract, and divide. So, generate unit tests for the fast decimal class to test for accuracy of computation. Okay. 2 of the agents generated the tests okay. And I gave up on Gemini, and I never used it again after this because it got stuck in loops and eventually hallucinated. ChatGPT did the best. Only 75% of the tests it generated failed. Claude Sonnet got the fast decimal constructor test right, nothing else, and generated tests using JUnit 4 for some reason. So wildly encouraging until now. So after a happy but fruitless afternoon, I tried all kinds of linguistic gymnastics to get ChatGPT at least to replace big decimal rather than delegate to it with some success. However, the code looked like it had been cooked with generous amounts of meths and the test didn't improve. They didn't compile either. So I decided this was all pointless and stopped the experiment for the day, convincing myself that I would have to be finishing this project by hand, and I hadn't decided to make this a subject of a talk at the point. However, the next day, nice sunny day, I went for a walk, came back, decided to give it another go. With some optimism because I hadn't tried Juni yet, and I'd heard a lot of good things about IntelliJ Juni. So first thing I did was clean up everything, and I'm in Git, so that's just a git reset minus hard. And the first prompt. Create a factory method of that accepts a string representation of a decimal value, and learning from the errors I made in the prompt the day before, convert that value to a scaled value for fast decimal using the scale factor and scale digits constants. This is the code it generated. Obviously, it's quite small, so it's not going to be easy for you, possibly not easy for you to read. But a quick inspection that I'll run through. Okay, looks good so far. So I'd also asked Juni to generate the add, divide, multiply, and subtract methods as well in a separate prompt, and then generate unit tests to validate these operations. And it generated an impressive number of tests, which all passed. Surprise, surprise. But I hadn't checked the rest of the fast decimal code yet, so I hadn't actually done a manual inspection. Remember, I am going to be doing a code inspection after the tests are generated. So there's also new AI behavior from Juni. The AI chatbots aren't capable of actually running the code they generate. At least I haven't found a way of getting them to do it. Juni, however, will iterate. It'll start off, it'll generate something, it'll change something, or generate something new. It will try to get it to build, and if necessary, it will iteratively correct this code until things work, which is fantastic. It's exactly what I was expecting from an AI agent, except it isn't, or at least it wasn't, as we shall see later, not really. And then, still not having gone through the code inspection yet, I asked Juni to generate a JMH test, or generate JMH tests, to allow me to compare the performance of big decimal and fast decimal for the add, divide, multiply, and subtract methods. The whole point of this is to see if I can get an optimized version of big decimal with some constraints on it to solve some of the performance problems that big decimal suffers from. It took Juni several iterations. In fact, I went and had lunch, but eventually got there. They didn't run inside IntelliJ, but the AI helped me sort out that problem too. We'll get to the results later. So, enough vibing. Let's inspect the code. What I found was that Juni generated and maintained quality Java docs and also added inline comments. There was way much more code generated than expected. However, my fault. I didn't say just the 4 operation methods. There were lots of other ones in there because the big decimal API is actually quite comprehensive. So, and a lot of these methods aren't needed. Things like moving decimal point right and left, don't need them because I'm restricted to 4 decimal points in the fixed decimal for the fast decimal class. Junie cheats. Well, actually, AIs tend to. It's not because they're willfully cheating, it's because they don't have anything that tells them not to. And inspecting the code immediately reveals some suboptimal code. Thank you, Jose, for pointing out that the fast decimal equals method has a performance scaling bug in it. And it generates a README MD, which actually basically tells me how to run the JMH tests. Worryingly, it also generates the requirements MD, which is quite amusing. If we've got time, we can have a look at it and see what it did. So, then I went to JAlber in May. Thank you, Maurice, for organising that. I thoroughly recommend JAlber as an unconf, not just JAlber, but also JChateau. Thank you, Jose. So, how does Junie cheat at tests? And we're actually doing this as an unconf session, which I did impromptu for JAlber. And the first surprise was we looked at the generated unit tests for the divide operation and quickly discovered they're all badly wrong. It became obvious that Junie was actually using the implemented operations in fast decimal to generate its own test data. So it's a self-fulfilling prophecy. Junie says, yeah, I've implemented the code, so it's going to be right. So I'll just use the code to generate the expected data. And no, doesn't work. So the cure was, and I did this live, create a JUnit test for fast decimal for the add, divide, multiply, and subtract operations using big decimal to generate the expected values, what I should have done in the first place. But I'm an inexperienced junior developer, so I wouldn't know any better. So this is the second surprise. Junie looped for several times on this. First of all, using jQuick, something I've never heard of before. Then it reverted this and finally generated JUnit tests as asked for. It also found bugs in its divide implementation and corrected them on the fly. So there's a scaling performance bug. Didn't see anything wrong with the equals implementation, although I didn't expect it to actually detect this, where if this equals object equals object return true, shouldn't have that in equals methods. And there's also a performance problem. They saw nothing wrong with the two-string method because in big decimal, two-string method is quite complicated, and it caches its two-string result. So I basically had to prompt Junie again, saying add a cached string value for two-string to cure that. Right. So all good so far. The next thing, the aim of this is to get things running on SIMD. So I started off with the vector API because GPUs are complicated and not really easily accessible. So the prompt was, add a Maven module to prepare for fast decimal operations using the vector API. Change the Java level to 24. What happened here? Now, I'm going to say, what do you think happened? Anybody? Nobody? Okay, this is the surprise and also a success. Junie creates a new Maven module for fast decimal vector and creates a POM XML for it using the parent POM. Great. It enabled the preview features and added the vector incubator module in the POM XML, but not in the run configs for IDEA. Also, this is a surprise. Okay, that's nice. It then created an appropriate package, org TLR fastdecimal.vector. TLR, by the way, stands for thread local random, which is an address or a domain I used for my blog, which I have neglected terribly for years and looking at reawakening that. It then implemented the fast decimal class for add, divide, multiply, and subtract operations for vectors. It's like, wow, I didn't ask it to do that. Happy, but that it did. It then generated unit tests, which were all broken because there were some other problems with the operation fast decimal. However, through generous prompting and some time, it also sorted that out. And it also generates the JMH tests, all from this one prompt. It's like, okay, fine, you don't need me, carry on, do it yourself. Okay, now we can have a look at the performance. Do I actually get some kind of, or is there a performance benefit of using fast decimal as opposed to big decimal? And the direct comparisons, as you can see, with the top two, add large big decimal, add large fast decimal, there is some performance improvement involved. And this goes further down, and you see more and more improvements. Chain operations, so I'm not just doing the one, I'm doing several, one after the other, using method chaining. And we come to the last one, which is quite surprising, possibly very suspicious, that it's a lot faster for multiplying large decimal, multiplying large big decimals compared to multiplying large fast decimal. This could be down to the fact that I'm just using long and I'm not expanding the data type to in case things don't fit. But it's still suspicious, so that's probably going to need some deeper examination, which is outside of the scope here. So, the conclusion. I've still got loads of time. So, what did I learn about using AI for development? Well, above all, inspect results after every single prompt. This is, unless you're doing something which is really obvious, and even then, you should actually look at what the AI has changed. This is obvious. I studied computer science and artificial intelligence at the University of Sussex between 1993 and 1996. And one of the first things in my first AI lecture was AI is not intelligence. So, and what we have today with AIs like ChatGPT and so on, they are really complicated and advanced inference engines, but they're not intelligent like we are. They're not sentient. AI will give you exactly what you ask for, but only for a given definition of what it interprets as what you're asking for. So for instance, if you're not very precise with your prompts, it'll think, okay, I think you mean this, and it'll go off and do that. So you have to be fairly precise with your prompts, otherwise you're going to be doing a lot of code reviews and binning and throwing things away. AI will often give you far more than you ask for, but also less. The first three attempts to generate even a factory method of produce garbage, and it didn't get any better after that. So it's given me more than I asked for because it's generating a lot of methods I didn't want. Even though I actually did say at a later stage, just these four methods, the big four operations, it still generated code for all the other things, shifting the decimal point left and right, and so on. So it gave me a lot more than I asked for, but gave me less because I didn't have anything that worked. So AI can cheat when generating test data for classes. You have to specify where the test data for the expected values is coming from. If you don't do that, quite often, you'll find that it uses the methods it generated to produce the expected data. And of course, all your tests will go green unless they don't build. Now, the quality of the prompts is only the beginning. You also have to severely limit the scope of things that you're asking the AI to do, which is what I did. Even this doesn't always work. The typical example, or the good example of that, is fast decimal vector. From that one prompt, it did everything, apart from get it to run in IntelliJ. Also, if the AI starts looping a lot, stop it. Just cancel the action and revise your prompt. Reduce the scope, be more precise. Junie is very polite, as most of the AIs I've seen are. Although Claude Sonnet irritates me incredibly because it's acting like a really apologetic and aiming to please chatty style, which I hate. Don't like it in people either. Make a mistake, own it, move on. I mean, okay, has everybody heard of this amusing story about the Claude Sonnet CLI, which and the guy was deliberately insulting you every time he got something wrong, and it eventually says, "Oh, I'm really sorry. I don't see there's any point in me being part of this project anymore," and deletes itself. I've seen the video. It's true. It did. It's like, and the more you insult it, the more apologetic it gets, but it eventually gets angry too, or at least it exhibits angry behavior. So be careful. You might end up with something, if you're on a Linux machine, just imagine, sudo rm rf slash and slash. So bye. Also, they're very, all agents never change things without your interaction. So with an AI chatbot, you get a snippet of code which you can paste into an appropriate place in your code. Or as an agent like Junie does, it will say, "Can I change things?" So if it makes a change in a POM, it will try the change, and then ask you if it's okay to do that. So before it commits anything onto your hard drive and into your branch, not committing to Git, but committing locally, it will say, "Do you mind?" Junie does have a brave mode, and I haven't tried this because that's scary. Yeah, just go ahead and do everything you want. It's like, nope, sorry. If you ask for something new, you only get it if it isn't actually new at all. The reason this is because the corpus of knowledge that most AIs are built on, especially things like ChatGPT and all the other big offerings or big agents or LLMs, are trained on was on the internet. So, and there's nothing new coming in. This is what I said about AIs are not sentient. They're not actually intelligent. They just work on what they have. And a lot of the mistakes they make, and this is probably obvious to all of you here, is simply because there's so much bad code out there, not just good. It'd be really nice if there was a coding LLM, which is just based on code written in best practices in all of the languages you might wish to serve. One of my problems at my job is RPG. I don't know if you have ever heard of RPG. Perhaps you have. It's the report page generated language from, or report program generator from IBM. First developed in 1957, so it's actually 7 years older than I am, and it's still in use today in various forms. And it is not. You can't use RPG code as a corpus for LLMs, which is really bad news, because we're going to be using these tools. AI tools. There's the new offerings from IBM. There are some custom-made tools from providers. And if your language is not really amenable to being part of a trained data set, then things get interesting. But you'll never get anything new. You'll only get what is already out there. And if you're lucky, the LLM will choose the good stuff. If you're not, then it won't. It'll choose something which isn't what you asked for or just basically wrong. So this is actually the end of the written part of the talk. So I just want to say the inspiration and thanks. So the people at J. Alba with Maurice, this is a conference you should consider attending, and not just for the whiskey. Edinburgh is a beautiful city. It's a bit hilly for my taste. I've got short legs, but we had a great time. So the actual unconf part was really good. We had some very good speakers there, and I was there too. So it's a balance. And Jay Chateau, which was my very first unconference, where I had the temerity to challenge Remy for about removing null pointers in Java, or a way of doing it. It was just a thought exercise. It wasn't. It was meant to provoke. There's some recommended reading. Kent Beck, Augmented Coding Beyond the Vibes. I actually read this after I thought about doing this for a talk, and I didn't actually plagiarize anything. And the excellent tooling from JetBrains and IntelliJ IDEA, which made this whole thing possible. I haven't yet used VS Code, but at work, I'm told I'm not allowed to use Junie for some reason, so I'm just going to pay for a license for myself. We use Copilot, and I'm not happy with that at all. because they got two versions. There's this multi-line code prediction, and there's also the chatbot, but it's a chatbot. So it can't do. It's not doing the things that I like about Juni, which is this iterating, running test. Does it build? Does the test pass? And so on. But it's still polite. But and thanks go last and not least, but to Devox on all you guys. Not just you guys who are sitting in the room trying desperately to stay awake, but also everybody. I've been coming to Devox since 2017, and I was, the first year, it's like, wow, is this what being a developer is really all about? This community, it's vibrant, it's full of energy, and it's just simply a load of fun, especially at Kelly's and Beer Central. By the way, I'm now on page 51 on the Beer Bible at Beer Central. So, you guys, it's all your fault that I'm here stood in front of you doing this for my first talk. So now we come to the stage, are there any questions? Or would you like to see me using Juni in action? Yeah? Okay. So, you know what this means. What I prepared for was, and it's something I noticed earlier today, it's missing a constructor. So I'm going to be getting Juni, hopefully, to add a fast decimal constructor through an of method that accepts the big decimal value as a parameter. Right, that's it. I'm just going to be, that's really dumb. I know this is probably not going to work. And then create the unit test for that. Don't need JMH. So I'll just exit this. So, do I need to make that bigger? Oh, it's not doing it. Hang on. You're in there? Yes. It's not working, so we'll just make you full screen then. Can you see that? Okay, so here we go. Create a fast. Because if I don't say create a fast decimal constructor, it might get horribly confused. Get out of the way. So that's it. What happens? So it's working. Really, I like that. Containing a high-performance decimal number implementation was opened successfully. Thank you for recognizing. No, okay, he's verified the fact that I haven't seen it yet. I haven't got one yet. Dum-de-dum-de-dum. And these constructors, if you're looking at real-world applications, this is actually quite important because the last thing you want to actually have to do is take the double value or the string value of a big decimal and then convert that to a fast decimal. So. Ooh. No. Okay. Let's see what this does. Come on, go. See what I mean about being polite? It's made changes. If they don't work, Juni will pull them back. So it will revert everything, which is really nice. Means I don't have to clean up a mess afterwards. Well, other than my own. Okay, so no tests were found in the specified test directory. I don't know why it says that, because they're obviously there, because then it'll then go off work and then find out what's going on. So, It's now working. Has it actually added a new test? Let's check. Doesn't seem to have done. I don't like keyboard. I don't like the mouse here. Ah, got it. Oh well, just get rid of the structure. Nope, hasn't changed anything yet. So one test failed. In test division for some reason. So it's actually running the tests, which have nothing to do with the new constructor. And now it's looking at, okay, why is there an assertion failure? It's taking time. This is good. Take your time. I've got 9 minutes left. Yeah. What a way to fill up your talk. La, 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 la. Ooh. Shows a failure due to mismatch between big decimal divisor precision and fast decimals full decimal. Ah, okay. So it will adjust the test to use a big decimal divisor with 4 decimals to match fast decimals of with small numbers. So the truncation behavior is, and we'll run the test, see what it does. If we've got time, I'd like to show you what it actually did for the vector API as well, because that's actually quite amazing. So, test pass. What did it change? Let's have a look in here. Open says me. Come on. Ah. Yeah. We don't need you anymore, so you can go bye-bye. And see what changed. Oh, I can just do a git diff. So, here we go. This is the new parameter. Added a method scaled from big decimal value, and which takes the value, throws the okay, takes the scaled digit. Just, can I make this? Yeah, I can. Excellent. So it scales things with a rounding round half up, which is actually quite important because I don't want to lose the accuracy. If I've got 8 decimal places, I need to have at least the 4th decimal place be rounded up correctly. And then it does all this scaled move pointed right, which is still on the big decimal. And then it gives me the long value exact. I'm not quite sure what that is. But it's, what does it do? Converts a big decimal to a long, checking for lost information. Has a non-zero fractional part. Oh, sorry, it actually takes account of the fractional part. Oh, ooh. So, okay, nice. You learn something about big decimal every day, other than that it's just slow. And what's it done in the test? In test division, so we can... So is it actually using the new... Doesn't appear to be using the new constructor, but we'll go over that. And now the test seemed to work, and it's this one that was causing the problem, it would appear. Never mind. So, okay. Seems to be good. What about fast decimal vector? I'm actually going to run the tests in without Junie. Actually, no. Junie. New test. Run. Why isn't my R working? Run. Just run them. Okay. So it's going. You big screen again. No. Ah, okay, it was blocked. And they all passed. So it would appear that although I've found an error in the divide method for the fast decimal class, the actual vector operations haven't been affected, don't exhibit this, or do they? All vector executing past successful without code changes. Woo! So just telling it to run the test actually will provoke Judy to look at the tests look at any tests which fail, and then find out why they're failing, and if it's a problem with the test itself, or more usually a problem with the method that it's testing, it will try and correct that, and it will keep iterating until either it stops, because Judy, I think, does 3 or 4 iterations on that before it tells you it can't find a solution. We'll roll back everything that you've done. Notice there's also a rollback here. Not sure it hasn't changed anything yet. So what about this code that it generated without me asking it to? What does this all look like? Well, here's a class. If I get rid of this. And it's just a whole load of operations. By the way, this has been expanded. I gave it a prompt, which is create methods which allow you to saturate all cores. So all of these vector cores on each CPU using parallelization. So there's a lot of stuff in here. Actually, I will go back to structure, and it works on arrays of long. So it extracts the scale value out of the fast decimal and prepares arrays for things like vector add, and then it will create the fast decimal results back as an array of fast decimals, which is okay. It's actually what I would have done, and according to people who know a lot more about this, like Remy, he says, yes, that's good. And also, it will do the same for the core saturation. So for each of these add, divide, multiply, and subtract methods, there are parallel versions which do more. So in add parallel, it will actually do the same thing before. So there's code duplication in here, but that's not important. What it does is it works out the ranges so that you can then use the parallel method in a stream to hopefully distribute everything onto the fork join pool, and hopefully have them running on. If I've got 8 CPUs on my machine, so I'm expecting 8 vector cores to be saturated with this. Obviously, if there's enough data, and the JMH will actually, the tests that are JMH tests that were generated actually generated something from 100, which is okay, up to 10,000, which guarantees that I'm going to be using, as long as everything's reaching the vector cores, that I'm guaranteed that I'm using at least one if it's single-threaded, and if I'm running multi-threaded, as this should do with the parallel. Let's have a look. If I could spell parallel, it would be great. Yeah, here. So that's it. Basically, the only thing it's doing differently, apart from using these range tasks, which is also an interface with 4 separate implementations for the different operations, it runs just with this parallel. And then at the end of it, it will give me, from the join, the array of the results. And this seems to work. I haven't actually checked. I mean, I don't do a simple, how quickly does this run compared to, how does this parallel vector operations, how quickly does that run compared to a normal parallel in single-threaded? And how does this compare to fast decimal without the vector API? And how does this compare to the big decimal performance? So I don't have any reliable JMH tests. Just a further thing about the JMH tests, these are non-representative. I do 5 iterations through after the warm-up phase, which isn't enough. I do 3 iterations for the warm-up phase, which is also probably not enough. I'm also using an OpenJDK. I'm using OpenJDK 24. I've been reliably informed that performance tests using the OpenJDKs aren't going to be that representative. You want to use a proprietary JDK like from Azure or from Oracle for this. And my greatest sin of all, which I know, is I'm running on a laptop. So I run into the problem of self-limiting, limiting the CPU to stop this thing melting through my office floor. So that's it, basically. Pretty much mission accomplished. Obviously, I have to do a lot more code review. And the idea is that this has real-world applications. So the plan would be to have this as a built on GitHub. It doesn't even have a build at the moment, so I'm not using GitHub Actions to build it. And eventually distribute this on Maven as a library for anybody to use at their own peril. With a big disclaimer, it's not my fault. This is all the AI. So, I'm actually at the end of my time now. Wow, I managed to do that quite good. So, thank you very much for being here. I hope I didn't bore any of you too much. And for what's left of DevOps, I wish you enjoy it as much as I'm going to, and have been. So, thank you.